everyone, this week we will be going over taking that further step, that next step into getting those Division I baseball stats and sending it to a database so you can store it and save it for later. I do apologize for taking so long to make the next video. Life just kind of gets in the way, and I do apologize about that. Sincerely, I know I pride myself on creating good content for everyone, so again, I apologize, but we are going to make a great video here. So, to begin, if you have not watched Acquire D1 Baseball Stats, my previous video, please watch it now because the data that we're using is from that video and it shows you how to acquire that data. So please watch that video if you haven't already, because we're going to take that data and put it into a database. I'm as excited as you are. So, you can see here in my global environment that we have batting and pitching stats. And we're going to just take a good glimpse at it. So we can see, it's grouped together by team alphabetically, but here's a thing that you might not want, at least initially. So when we go all the way down here, we'll see something like totals and opponent totals. Now, obviously, you'll want that, but you'll probably want that in a different data set. So, let me show you how to do that first. So, we know that our initial data set is D1 batting, correct? So, if we want to remove that, or at least put it in a team setting, we can say D1 team batting, and then say D1 batting, that piping operator, though I should say let's load in tidyverse first. So, make sure you load tidyverse in first. Don't want you to forget that. D1 batting, piping operator, and then we'll say filter from the dplyr package. And what we're going to filter is instead we're going to use a string or string detect. So from the stringer package, we're going to use string detect, and in quotes we're going to put parentheses. We're going to say totals. And so what basically this filter does is it will go through the string, which in this case is player. So let me add player in there too. Add player, and then it'll search for totals and filter that data set by totals. So we'll run this. We can see that there's 582, but here's the thing, it also grabbed opponent totals. So we're going to have to remove that. So here's the way you can do that. Same thing, D1 team batting, but instead now we're going to say D1 team batting, piping operator, filter, and we're going to say player does not equal opponent totals. So we'll run that, and we can see that it is cut in half, that data set. So now I have totals for all the teams and their games. So let's do the same for pitching. So I'm just going to copy and paste for you, and we'll say D1 team pitching, D1 pitching, and same thing, string detect, etc. So team pitching and team pitching. So we'll run that. Now we have the pitching data as well. So what we're going to do next now is we want to remove the totals and opponent totals from the original data set of individual players, since you already have that in a separate data set. So now we'll go down here, we'll say D1 batting, piping operator, and again we'll do a filter. Now there's multiple ways you can do this, and I will show you multiple ways of doing this. So one is you could do string detect, player, and again totals, but this time on the outside you'll say double equal sign F for false. So that I'll basically just say filter the data set where player does not contain totals in the data set. Another way you could do it, so I'll just say alternative way. Then I'll go down here and say player does not equal totals. Or, so that vertical line means or in R. Player does not equal opponent totals. Now, either way will do the job. Really depends on what you're more comfortable with. If you like to filter it out that way, you can. So we're going to do that. And we can see that we removed those 291 observations with that. So now we're going to do the same for pitching. And again, up to you. Either way will work the same. Whatever you're more comfortable with. Thankfully, we have the tidyverse package loaded, so you can use string detect without having to load an additional package. So, same for D1 pitching. So now we're going to have all of our data sets wrapped up together. Team batting, team pitching, batting, and pitching. Now we're obviously, the one thing is we're going to have to filter out some of these players because some of these guys don't have an at-bat, don't have a plate appearance, etc. So you can kind of see NA. And you can kind of see that some of these players are just, pitcher only. Now, there's one way you could do it. You could filter by position equals pitcher, but the thing is, on the NCAA site, that's not always the case, especially when you get to lower levels. At D2, D3, there's going to be some two-way guys, or more likely to be two-way guys, down there than there is up here at the D1 level. So there's different ways you can do it. Now, the thing is, though, you don't want to filter by just at-bats because there are going to be some observations where a player maybe doesn't have any at-bats, but he does have plate appearances. So maybe a player had 2 plate appearances and he walked both times, or he walked on one and got hit by pitch on another. It'll be listed as no at-bats, but he'll have 2 plate appearances. You can see here that there's no column for plate appearances. So we're going to create that, and then we're going to filter by where plate appearances is greater than 0, so you can have that data in there. And then same on the pitching side, but the pitching side's much easier because you can filter by batter's face is greater than or equal to 0. So what we're going to do in here at first is we're going to figure out the variable types of our data set. So you can do an sapply D1 batting class, and what essentially that does, it just gets those values. So you can see here something like we have a bunch of characters and numeric variables. And we're going to have some NAs in there in our data set, as you may have seen already, and we want to be able to convert those NAs to 0. So let's do the same for pitching just to make sure. So sapply D1 pitching class. For the most part, it's pretty much the same thing. So what we're going to do next is convert those NAs to 0, get that plate appearance column, and then filter the ones that have at least 1 plate appearance, and then filter on the pitching side pitchers who have faced at least 1 batter. And then we'll be able to upload it to a database. What we're going to do here is on the D1 batting data set, I don't know what I just said, D1 batting, piping operator, and we'll say mutateif. And so what essentially mutateif does is whatever assignment you give it, those columns will change. So in this case, we're going to say if these columns are numeric, we're going to replace NA. And this is from the tidyr package. And it just simply replaces NAs with whatever you want. And in this case, we'll say replace equals 0. So we'll run this. And we'll go back into our data set. and now you can see zeros instead of NAs. So now what we're going to do next is now create the column for plate appearances, which are essentially just at-bats plus walks plus hit by pitches plus sacrifice hits plus sacrifice flies. And then filter it out. So I'm going to do D1 batting. A lot of repeats here. D1 batting, mutate, PA equals at-bat plus walks plus hit by pitches plus sacrifice flies plus sacrifice hits. Then actually what you could do here is just within that same line, you could use a filter and just say PA is greater than or equal to 0. Or actually, PA is greater than 0. So that way you only get observations where there's at least one batter or one plate appearance. So on the pitching side, we're going to do the same thing. So D1 pitching, and again, mutate if is dot numeric, replace NA, place equals 0. In this case, I'll open up the data set for you. And you can see a lot of NAs here. So in this case, you don't have to create a new column. We'll just go for BF, which is batters faced. So what we're going to do here is then say filter BF is greater than or equal to or greater than 0. You could also say greater than or equal to 1. It does the same job. So I'm going to run that, and now we can see our data set is now filtered by guys who have had at least one plate appearance and pitchers who have faced at least one batter at the Division I level. So now we're going to get to the fun part, which is creating a database, uploading the data to the database, and then saving that database so that way you can access it for future reference. What we're going to do here is add in 2 packages that will be necessary for acquiring and uploading to the database. So I'm going to say library DBI, not BDI, DBI, then library RSQLite. Now, if you don't have either of those downloaded, just simply install that packages and then DBI, and then install .packages RSQLite. And so you'll remove these comments here, and then you'll just run those lines, and a message will pop up just to say it's downloading, and then when it's done downloading, it'll say it's done. So then we'll run these libraries just to add it into her. Now we're going to create the database, and we're going to call it just D1DB. And we're going to say D1DB. From the DBI package, we're going to say DB connect. And so the first argument, which is required, is the driver. And in this case, we're going to use a SQLite database. Now, there's different databases that you can use. I'll leave a link in the description below if you want to learn more about those different databases. SQLite is just a real simple local server database that you can use to store data. So I think it's great in this specific use case. So I'm going to say SQLite with the parentheses, and then we're going to name the database. You can name it whatever you want as long as there is a .SQLite at the end. So I'll just call it division_1_db.sqlite. So what that basically does is it creates the database and allows us to then add data, write data, etc. So now we're going to say db write table. And so this is the way you will add data sets to your database. In this case, we have 4 different data sets: batting, pitching, and team pitching. So we'll have to run this command 4 times. So first argument for our db write table is our connection. In this case, it is the D1 database, known as D1_DB. Then our name, call the name of the data set whatever you want. So I will say division, or I'll say D1_ and then caps batting. so that we know it's individual batting. And then the value in this case is the data set. So in this case, it's D1 batting. And we'll add extra arguments, which are, we don't want row names, so row names equals false. Append equals false, and that what append does is just basically adds more rows to your database if you haven't already, or if you have already a database or data in your database. And then we'll say override equals true. And since we're acquiring these D1 stats week by week or day by day, whatever amount of time you do it, use that overwrite so that way you have the most updated data. So we're going to do that. And I'm going to just copy and paste this down 3 more times. And I'll just add, so D1 team batting, D1 pitching with a capital P, and then same for team pitching, team underscore pitching. And then change these around as well. So D1 underscore team underscore batting, and then D1 pitching, and then same here, D1 underscore team underscore pitching. And so what these next 4 lines will be doing is writing those data sets to our database that we created. So we'll just run those 4 lines. And then this is just to disconnect your database. This is actually very important. So make sure whenever you're working with a database in R, as you run this command db disconnect, there are times where you might lose data if you aren't careful with this. So db disconnect, the name of your database, d1db. Now what I'm going to do next here is reload in the database and then write just a basic SQL query of pulling at the specific data. So I'm just going to copy line 32, bring it down here, connect our database. And now I'm going to name the data set a different name. So in this case, let's just do all caps, so D1 batting, all caps. And now we're going to say db get query. And again, what's our connection? D1 underscore DB, and then our statement. Now this is getting into SQL queries, SQL. Again, I will leave a link in the description below on what the different types of SQL databases there are. I'll also leave a link of something I've used to help me learn about SQL a little bit from W3 Schools. But this is a very basic statement. And so SQL is just basically built on writing these specific commands to acquire data. So the command is select star, which essentially that just means all observations from, and then whatever name you named your data set. So in this case, when we go up to line 34, we see that I named the individual batting data set D1 underscore capital B batting. So we're going to run that, and we can see that these observations match, because now we have it in our data set, or in our database, I should say. And we have plate appearances all in there. So we're going to do the same thing with the other ones. So I'm going to just copy and paste these 4 lines again. And instead I'll say pitching, pitching, and then team batting. So I'll just put team batting, and then team pitching. Let me change this to team pitching so we get the correct data. So again, we'll just run these queries again, and you can see those observations match what we've just put in. So there you have it. You now can store Division I baseball stats of everyone from this season into a database. And you can update this weekly, daily, however often you want to run all of these commands. So make sure to rewatch this if you aren't fully grasped with the acquired D1 baseball stats. This is basically the code. and then run this code I should say, to filter out teams versus individuals, create data sets for teams, and then filter out players who don't have a plate appearance or don't face a batter. And then upload it to your database, it's good to go. So the last line I will run again is db disconnect d1 db. So thank you so much for watching. I really appreciate you taking out the time to help yourself get better, and I hope this video was of use to you. So again, thank you so much for watching. Have a great day.